The last idea for section 3.3 is actually one we've kind of gone over in another chapter, this idea of a difference quotient. But we're actually going to do the idea behind that. So again, I mentioned back then I kind of disagreed with where the book put it, but it is what it is, so let's take a look at it. And what we're looking at here is called the average rate of change. And then from that we can look at what's called secant lines. And then from that we actually build the difference quotient. So it actually all starts here. And so to understand the average rate of change, let's go back into our past and remember what's our slope formula, right? So for a line, right, with an x1, y1 on it, and an x2, y2 on it, right, what was the slope formula? Okay, and so we had y2 minus y1 all over x2 minus x1, right? That's our slope formula. But now what we're doing is y is no longer y, we're using function notation. So this value here, right, is the y value when x is put in there, and this is the y value when x2 is put in there. So when we put this in here, y2 is actually the function value at x2, y1 is actually the function value at x1, and then x2 minus x1 are basically the two input values. And so the only thing that will change on this is if we have an interval. So again, let me start putting a picture here. If this is actually the value of A and this is the actual value of B, so if I consider an interval of action, if you would, for this going on, the only thing that'll change in this is the bottom becomes B minus A. That's basically, again, the length along the x-axis. This is the function value at B minus the function value at A. So kind of playing around with our initial idea of the slope formula, introducing the concept of functions, and then introducing a concept of an interval, we have what is famously known, is the average rate of change formula, right? And this is over the interval A to B. So what we're measuring, just like slope does, is for a change in x from B minus A, what's the change in y, f of A and f of B, and then we put those things in a fraction and we basically get our rate of change. Again, back in the old days, since the beginning of algebra, and I think it was in our case, section 2.2, we're basically talking about slope, rise over run. So my vertical change, my function value changes over my horizontal change given an interval. Okay, so what I'm first going to do is throughout this page is take a look at finding the average rate of change for different situations. So in the first one, the function that we have is actually given as a picture. And so the average rate of change over the interval, well, here's your A and here's your B. And so visually what we're doing is our first value is -3 and our second value is B. So we're getting an estimate, right? What is the average rate of change of this function over that given interval? It's a pretty big interval. And so by formula, this is basically f of 4 minus f of -3 all divided by 4 minus 3. And again, here's our, let me rewrite the formula a little closer here. Right, so f of b minus f of a, my vertical change, over b minus a, which is my horizontal change. Doing the math, the bottom is 4 plus 3. The top, if we look at f of 4, right, 1, 2, 3, 4, it looks like it's -4, and f of -3 looks like it's +3. And so upstairs we get -7, downstairs we get +7. So it looks like the average rate of change on this interval is -1. So what that tells me, if we, again, getting ready to draw the secant line, if I go from this point to this point, on average, right, the function is going down by a rate of -1. Now, of course, we actually see that the function is going down and then up and then down. So the rate of change is actually constantly changing, but we're considering just, again, that's the word average. Overall, what seems to be the general direction on this interval, we're going down. And you can literally see this, right? We're going to go down 1 and over 1. down 1 and over 1, 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 and bam. So that's consistently that idea of what that -1 means. Down 1 and over 1, and we end up getting at that point. So on average, as we move along, the function's on its way downward by a rate of about -1. So what happens when the function's given as an equation? Well, same idea. All right, so here's the interval. We're going from -1 to 3. So the formula, my average rate of change formula, is that. So we are looking at f of 3 minus f of -1 all over 3 minus -1. And in this time, to find f of 3, rather than having a graph to use, we have a function. So let's just evaluate that. That's 3 squared minus 3, which is 9 minus 3, so we get a 6. Minus f of -1, so plugging that in, we get 1 minus 3, that's -2. And on the bottom we have 3 plus 1. So we end up with a 6 plus 2 upstairs over 4. This is 8 over 4. We get a value of 2. Okay? So the rate of change then, whatever this graph looks like, again, let me try to get visual here. Whatever that, it's a parabola actually, but whatever this graph looks like from -1 over to 3, the function value at 3 is 6. 1, 2, 3, 4, 5, 6. The function value here is -2. So what is the, that slope of that line? It's 2. So whatever that function looks like from here to here, the average rate of change is 2. Alrighty, and we can even answer the next question. Based off of your work in part A above, is the function increasing or decreasing? Well, it's obviously increasing, right? Because we have a positive average rate of change. So that tells me that every 2 up, we go over 1. Every 2 up, we go over 1. And again, the function might be doing something else. Again, it's a parabola, so I think it's going to be doing something like this. But over that given interval, the function's on its way up at a rate of 2 over 1. Okay, so that's your average rate of change. All right, the next item up for vid is this idea of a secant line, and I'm going to address that in another video. All right, see you guys then.